I hope you're having a good time. We haven't started yet. My name is Walid. Your main presenter today will be Vlad. I am a platform engineer and AWS container hero. And I'm quite active with some of the CNCF ambassadors in the background. So you might see me on CNCF TV, or you might see me on clustered episodes or stuff like that, and in collaboration with other CNCF meetups. Vlad is a very well-known AWS hero. I think he has a famous reInvent presentation. I hear so. Maybe he can tell us more.
Yeah. Hey, everybody. It's an honor to be here with all of you. So, as Walid and Anna said, yep, I'm a container hero. I do have a relatively nice, I would say. I'm not sure if I would say it's famous, but I did present at last year's reInvent a benchmark of scaling containers on AWS. So, I'm a consultant. I like to joke that I'm a professional mistake avoider, which is surprisingly accurate for my role. So I do a lot of work on cloud native application, both with serverless and containers. And a lot of my focus is on empowering developers to move faster and focusing on developer velocity and observability. In my day-to-day job, again, I'm a consultant. I do a lot of fractional CTO work, strategic advisory, board membership, and other way too fancy sounding roles. But yeah, I'm super happy to be here with you. As we've discussed a bit earlier, I know not everybody was in the room. The internet is being a bit weird today. So I pre-recorded the talk. I actually finished recording it like 10 minutes before we started. And it's gonna be my first time actually playing a pre-recorded talk in Zoom. So we're gonna see how that works out. The plan is we're gonna do the talk, if I'm not wrong, and then we'll have a Q&A. I really try not to have a boring talk where I'm just speaking for an hour and a half and completely overloading you with all the details about containers. So that's not the plan of this series. The plan of this series is to give you an introduction and to make you comfortable with containers, to give you a solid base. We don't want to bore you with 4 hours of how you can run containers and what's the difference between different container runtimes and things like that. And yeah, also, we're super open to feedback. Again, this is the baby of Anas and Walid. They are it's their idea. They're super involved and they co-opted me in. So if you have any feedback or anything specific that you want to see, please let us know. We're super open to feedback. So yeah, anything else to add, Anas, Walid, or should I just start the presentation?
One important thing, there will be a giveaway, 3 AWS vouchers. One voucher will be the most interactive person that asking the right question. And the 2 other giveaways will be a raffle, correct, Anas?
Yes, sure. We can do one for the most interactive and raffle on 2 questions, maybe.
Yes.
Yeah. So the first one who answers the questions in the chat would get the voucher. Does this
work?
work?
We can do this. Okay. So basically, who asks the best question and who answers our questions, and then one by choice. The floor is yours, Vlad.
Awesome. So I just learned how to do this today. I'm gonna need y'all to confirm that this is working. Give me a second. Video. Yes. Share. Open. And you should all be seeing a black screen now. Is that accurate? Awesome. I'm gonna stop my webcam though, and I'm gonna hit play. Let me know if this actually works. Give it a second. Hello, everybody. I'm Vlad, and I'm going to be your presenter today, and the annoying face sitting right here in the corner. As you know, this is the first presentation in the 2021 series of container meetups organized by the AWS User Group Dubai. Specifically, this is the 8th meetup of the group, and we'll be doing an intro to containers. Let's discuss the agenda for today. First up, we'll discuss the reasoning behind running containers, and then we will discuss how we can actually run containers. After that, we will of course end up with a Q&A, and we will move to the actual social chit-chat part. We will be discussing and answering all your questions, as we've been trying to keep this presentation quite short and not overwhelm you with information. A short and to the point agenda. We'll try to keep you entertained. Before we start though, I want to thank our organizers for setting this up, and I want to thank them for all the work they're doing for the AWS community. Thank you, Anas, thank you, Walid, and thank you, Ahmed. Your work is really appreciated. I also want to thank our sponsors for this series, AMD. Without them, we couldn't have done this series, so thank you, AMD, for sponsoring these events. That's all covered, so let's get right to it. First up, let's discuss why containers. Why would we even want to use containers? Let me actually rephrase that question. Let's change that to, how do we run our apps? What I mean here by apps is generic apps. By that, I mean apps that don't have any exotic requirements. Apps that require a certain CPU architecture, applications that require, specific hardware like Intel InfiniBand or stuff like that. That's not our focus. We are focusing on applications that can easily run in the cloud, not very, very specific pieces of tech. So, how can we run our applications? Well, we have a couple options. We will only be discussing options that are valid today and that are still being used. We're not going to be discussing SSHing into a server and manually deploying your applications, nor are we going to be discussing FTP copies and things like that. Those are not valid ways of running an application in production today. That's not something anybody should really be doing. So, getting back to it, the first option is VMs, of course. We can run containers, or we can run serverless apps. Interesting. Let's take them one by one. So, VMs. Well, they're the classic way. VMs work significantly well, we know the drawbacks, and everything is very well documented. We've been doing this for a while, like we know how VM runs, we know the pitfalls. People don't have to have any special upskilling into this. It's been done for a while, it's been the rule of the law. But it's not all great about it, is it? With VMs, you can get into big dependency messes. On a VM, you have only one shared file system. Everybody has access to the same thing. If you're doing stuff like, having multiple versions of an SDK or multiple versions of a library, that can get very, very, very weird. There's also high risk. What if one of your applications goes absolutely berserk? Say it fills the disk with logs. Say it maybe, suddenly start using a lot of CPU. Now, some of you will be saying, okay, we know how to manage against this. The kernel is smart. We can handle this. That is very much true. We know how to do it, but it's still risky and it is not that easy to configure that in a reliable way. A bigger problem though is low utilization. VMs have a lot of headspace. That means, especially in the cloud, that you're paying for a lot of processing power that you're not using. That is very, very much hurting your business. And we've got scheduling woes. We'll get into that a bit later. The biggest problem of VM those are the deploys. You get to pick between two things. Deploys that take very, very, very long, or deploys that are rather fragile and risky. You can either do AMIs, you can use instance images that take a while. The shortest deploy cycle is about 30 to 45 minutes, which is absolutely terrible and leads to very low developer velocity. Or the alternative is that you can have a bit more fragile deploys. Say VMs pull the applications, like when they start, they pull the latest version of the application. But that's fragile because you've got to do a bunch of checking. You have to do a bunch of stuff to make sure the application starts. You have to make sure that if there are any issues with the new version of the application, you can still launch the old version, and so on and so forth. That's not good, and it gets quite complex. And all this is leading to low developer velocity, which is very much hurting the business. So VMs, maybe not the best idea. Let's get back to it though. We started with VMs, but let's go to the other extreme. Let's go to serverless. Serverless is new. Serverless is cool. Unlike VMs though, serverless is very, very, very cost efficient. If you're not familiar with serverless, serverless is basically when you throw code to AWS and you tell them, hey, run this for me. They do everything for you. They handle everything and they only bill us when the code is actually running. So if you have an application that has very low usage or no usage during the weekend, for example, you will not be billed at all during the weekend. That's awesome. You are only billed when the code is running, and that is very, very, very cost efficient. Serverless also scales very fast. The cloud provider is managing everything and they can scale super fast and do some very nice capacity management for you. With serverless, there is a lot of effort offloading. The cloud provider, AWS in our case, manages everything about this. You can let them pick up the undifferentiated heavy lifting. They will do that for you. That allows you to better focus on your application, to focus on your business, and is a very, very, very big advantage. No more stressing about OS updates, no more stressing about having to patch up an SSL. This all leads to extreme developer velocity. And when I say extreme, I mean it. People can move very, very fast. They can fix a bug very fast. They can come up with new ideas or new features very, very fast. They can move and they can put something into production very, very fast, which, say, against a competitor of yours, very big advantage. We've seen, especially in the times that we're living right now, how being the first to market with something can be a very, very big advantage. But serverless is not all good either, is it? You have a lot of resource limitations with serverless. For example, in AWS, you cannot run for more than 15 minutes, and you can use at most 10 gigs of RAM. You can only use half a gig of local storage. Not ideal. You also don't get stuff like 10 gigabit network either. Not good for some apps. The biggest thing, though, is that this is greenfield. This is all new. Serverless is new, and the landscape changes a lot. You need to be up to date with everything that is happening. That requires a lot of maintenance and a lot of effort, a lot of staying up to date with everything. The developer experience, since this is new, is also not that polished. It's very much running and it's mature, but there are still some rough edges that are not ideal. The biggest drawback, though, by far, is that serverless, through its limitations, requires re-architecting and rewriting your applications. That's painful. That is really, really not good for any older projects. And by older, I don't mean stuff from the 1990s. No, I mean for everything that is not completely new, you pretty much have to re-architect and rewrite your apps. You have to become a cloud expert first. You have to get familiar with all the serverless patterns, with all the serverless best practices, and so on and so forth. For those of us that have a lot of legacy applications and a lot of applications that are running very, very well, allocating that effort is not even an option. So we have the VMs, we have serverless, and in the middle, of course, we have containers. Let's recap a bit. VMs are well known. There are some issues with dependencies and they come with a very high cost due to the low utilization. Serverless is fast and cheap, but the user experience still has some issues and serverless requires rewriting of the applications, which is a pretty big ask. Containers are in the middle. Containers are moderately new. Like, we've been using containers for a while, we know about them. They're not as new and unknown. The field is changing often, but not as often as serverless. Containers have a moderate cost. They do optimize the cost. Compared to VMs, they do try to maximize resource utilizations. So there won't be as much unused space as we would have when using VMs. But we're not reaching that serverless pay-per-use extreme cost savings. Serverless is still better at that. Containers are moderately fitting. You can get most applications and you can put them in a container. If you're running something that is relatively modern, like not Java 6, you can get it and you can put it in a container without that much work. You can put in a lot of workloads in a container because containers are building up on the history of VMs. You don't have the limitation of serverless, and if your application needs, 100 gigabit network connections, you can easily do that. You are not limited by the newness. Containers are also rather fast. They scale fast, faster than VMs, but not as fast as serverless. What I'm trying to say here is that containers are the middle way. They're the most flexible option between the three options we have. Serverless is new, it's awesome, but it's limited. VMs have a very high cost and they do come with risky deploys. Neither of them are ideal. Containers sit straight in the middle. They fix most of these problems by being flexible. And that's important because that flexibility led to a lot of software being written for containers. If you're running containers, you can take advantage of so much software. Let's, think of scaling. You want to scale on a specific metric combination with complex math? You've got a bunch of options you can choose to. Is AWS CloudWatch not enough for you? You can replace CloudWatch with 10 different open source options that you can configure and tweak to your liking. That's awesome. A community was created around containers and massive software opportunity were created. Containers, by offering an abstraction layers, allowed open source to thrive. Think of it like this. You're a big company and you need a machine learning pipeline. What if instead of writing your own custom ML pipeline, you could use the same machine learning pipeline that other two big enterprises use? You would be offloading a lot of effort. You'd be sharing the development effort and the development cost with the other two companies. It won't just be your company, it would be a community. It's a win-win for both companies, for users, and for developers. There is so much software you can use when you're running containers, and that is a competitive advantage. So, to recap, containers are flexible. That's why we run containers. They're flexible and they allow us to focus on delivering business value without wasting money or having to rewrite everything. Let's see how this actually looks because I'm more of a visual person. So, first of all, we're in AWS. In AWS, we don't really have VMs. EC2 is already virtualized, so it's a VM already. A server looks kind of like this. You have the host OS, you've got some dependencies shared between all the applications. So if you have, say a Go application and a Java application, both Golang and Java need to be installed on the machine. You share those dependencies. For some tools, sharing dependencies is easy. For other tools, it's a fight and it gets very, very complicated. What happens if somebody installs Java 8 and your application is Java 6 specifically? Ruby version management is also not ideal. Some dependencies can get very, very ugly in a hurry if you need more than one version. But as we discussed earlier, one app can just go completely off the rails and bring the whole server down. What if one app starts filling the machine? What if it suddenly starts eating a lot of CPU? What if it starts using all the memory on the server? Not ideal. But most of all, look at all that wasted space. That is basically wasted money. We need to have some headspace here. I'm not denying that. When more requests come in and our app needs to respond, it's going to be using more resources. It's going to be using more memory, more CPU, so we need that headroom. But still, that is a lot of wasted space. So much wasted space and so much wasted money. And we're not actually just using individual machines. We're using auto-scaling groups. We're using groups of machines. The problem of wasted resources gets even bigger. But another problem creeps up. Say you have two auto-scaling groups. Group 1 on the left is running some applications. Group 2 on the right is running some other applications. Say Group 2 is reserved for applications that have very high networking needs. Stuff like video streaming, stuff like games, stuff like machine learning. We have these two auto-scaling groups and they all launch instances that look like this. Awesome. We get a new app. Which group are we gonna put it in? I mean, you kind of fit in the first one, but it would also fit in the second one. We could start with the generic group 1 that is built for most applications. It would fit there. But it would also very well fit in the second group because while our new application is not very network intensive, it is somewhat network intensive. So where should we put it? How should we maximize the utilization of our instances so we don't throw money away? That's not an easy problem to answer. It's pretty much impossible to do this when doing virtual machines. Say you've got 20 applications. Where are you going to put the 21st application? We've got to think about it. We have to manually spend a bunch of effort to do this. We have to have a bunch of meetings. We have to agree on a bunch of things. And then we finally reach a decision. Of course, the application behavior fully changes 3 months later and all our thinking was for nothing. Are we going to remember that we have to move the application to another server group? Are we going to remember that we have to reevaluate that? Will we spend that effort again? Not really. Containers, of course, solve this. Containers are an easy way of packaging an application with its own dependencies. Some people say to think of containers as tiny VM. That's definitely not a correct abstraction. Containers are not VMs. Containers do not offer the same separation and features as VM. But this is an abstraction that makes containers very, very easy to understand. You can kind of think of containers as the tiniest VM possible. If you don't know what a VM is, think of your laptop as an image. We're taking a snapshot of your laptop. But we don't actually need everything on your laptop, do we? We don't need a calculator app. We don't need a media player. We don't need all that. That would be a VM kind of issue. Containers are just bare bones. Containers are just what you need for your app to run. Your runtime and your dependencies. A very, 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 very tiny VM. As tiny as it can be. You've probably seen images like this with nicely packed wells. Containers are pretty wells. Containers are just throwing your application and all its dependencies in a nicely wrapped package. Well, kind of. Again, this is a high-level abstraction that is not entirely correct. If you actually want to dive deeper, we can quote the fabulous Alice Goldfuss. Containers are processes born from tarballs, anchored to namespaces, and controlled by cgroups. That's the technical way of saying containers are a way of isolating processes using native Linux kernel features. So, each pretty well is actually an isolated series of processes. Processes with their own file system, well, share of their file system with their own share of the underlying machine. There's still processes, though, happening on a machine, so you cannot run a Windows container on a Linux node. It actually all looks something like this. We still have the host OS, but on top of that, we have the container runtime. We're going to get into that next week. Don't stress about it now. The container runtime is in charge of actually starting the containers and taking care of them in case they have issues. So we have our containers here. They are color-coded, so each of them is an application. Note something here. Each application comes with its own dependencies. There is never going to be another conflict between dependencies. Each application can go and do whatever it wants, and each team gets proper way of moving faster. This is how containers compare to VMs. If one application has an issue, the container for that application can just be terminated. We can easily terminate only that tree of processes without impacting any other running application. If one application has a very, very big dependency, say, I don't know, a 20 gigabyte dependency, just that application is going to pull it. If that application is not running on the server, we're going to save that disk space. Again, applications can be independent. That leads to team being able to work independently. Teams don't have to discuss with the operations team to get something installed on the servers. Teams can update their runtimes faster, for example. If one team is ready to move from PHP 6 to PHP 7, they know they can safely do that without impacting anybody else. They don't have to have a bunch of meetings. They don't have to talk to ops. They can just go ahead and do their work and deliver value. They can manage their own application and their own dependencies. That is a very, very, very big advantage. So containers are independent, isolated, and easily controllable processes running on a machine. You can see how we can kind of think of them as pretty isolated wells. Again, not technically very correct, especially not from a security standpoint, but it makes sense. Each well is a container isolated and not knowing about anything else running on that server. Each well can be easily replaced or restarted without impacting anybody else. Makes sense. But we don't just have one server, do we? We have multiple servers, all of them running containers. How do we actually run containers in production? Let's discuss how we can actually run containers. Again, we're in AWS, so we will be looking at options in the AWS realm. You can install and do your own way of running containers, but we won't be covering that here. First of all, we have Amazon Elastic Container Service. This was historically the first option. After that, it came the Amazon Elastic Kubernetes Service. The latest option is AppRunner. This is a fresh offering that came out just this spring, so it is quite rough around the edges. For example, you cannot connect to anything in a VPC right now from an app running on App Runner. That's a pretty big limitation. So we'll count this out for now, but I highly recommend you all keep an eye for it. App Runner will be awesome in like a year or something. And that's it. Yes, some people would include Lambda containers here too. That's more using containers as packaging, and it works in different ways than most people would expect. It's closer to serverless than to containers. Kind of have to do some tiny bit of rewriting, or it's going to be a very painful experience. I wouldn't include it. Others would also like to include Elastic Beanstalk here. As we learned with the UpRunner launch, Elastic Beanstalk is now in maintenance mode, so we should stay away from it. Of course, existing services will run just fine, but using it for new applications is perhaps not the best idea. Others would also include Lightsail containers, and frankly, they'd be right. Lightsail containers are an amazing, amazing service, but it's a better fit for early stages and experimentations. You can take advantage of all the power AWS gives you, so I'm agreeing or not including it. For a quick way into containers though, and for a quick intro to the cloud, it is an awesome, awesome, awesome service. So let's get back to the two main ways of running containers on AWS. ECS and EKS. Those are the two main options for running containers today. We'll see what the future brings. Both ECS and EKS work under the controller worker pattern, or better said, control plane and worker plane separation. What is that? Of course, it's controllers and workers. That does not help us understand it though. The easiest way is to think of it like this. A big brain and a bunch of workers. The brain decides what work happens and where. The big brain decides on what nodes containers are running, for example. If a node starts getting weird, the control plane will take care of replacing that node with a new healthy node and so on. Typically, those workers are auto-scaling groups, but they can also be serverless workers running on Fargate. When you use Fargate, AWS gives you a virtual node, kind of a virtual tiny EC2 which runs just your containers. It's basically telling AWS, hey, find the necessary infrastructure so I can run this container. Not having EC2s also means you don't have to stress about patching those EC2 instances. You don't have to stress about OS upgrades. You don't have to stress about OS rollouts. You don't have to stress about having to patch OpenSSL and SSHD. No, nothing. It's way, way less stress. Usually, though, people run a combination of auto-scaling groups and Fargate workers. How does this all end up looking in production? Well, it ends up looking something like this. You have the brain. The brain still makes all the decisions, and you have a bunch of worker nodes that actually run your application. In the case of ECS, so if you're using ECS for the brain, there's also an AWS ECS agent on each node that reports back to the brain what is happening. That's how the worker nodes communicate with the control plane. Each node reports its status to the brain thinks and makes a decision, and then the brain sends the decision back to each node, which has to actually implement that decision. In the case of Kubernetes, the agent installed on each node is actually called a kubelet. So does this mean that ECS and EKS are pretty much the same thing? No. I mean, both have a brain and they both have worker nodes, but that's it. They both use the same patterns, but they're not the same. Let's compare them. So first up is ECS. ECS is tightly integrated with AWS. Since this is an AWS offering, AWS is writing all the code and all the integrations. This results in ECS being very, very, very closely integrated with AWS, which is an advantage. ECS is also a fully managed service. That means AWS is the one that is managing ECS and setting guardrails for it. ECS is basically the straightforward choice. For many people, that is awesome, and it is a very, 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 very valid choice, and they should be using ECS. For others, though, ECS is not enough. So let's move on and discuss Kubernetes. EKS is a managed Kubernetes offering from AWS. So instead of you having to configure and run the brain, AWS does that for you. This is both a good thing and a bad thing. It's good because AWS has a lot of highly skilled engineers that know very, very well how to manage that control plane. Managing a bunch of services and a database, that's what the EKS brain is actually made out of. Managing all that is not easy. On the other hand, this can also be a limitation for some because AWS does not expose you all the settings you may want to change. AWS is focused on reliability, so you get no access to experimental features, for example. For some people, that matters. If you need that, you can always run your own brain, but let's not focus on that now. The big deal about EKS and Kubernetes itself is the fact that Kubernetes is open source. Google, Red Hat, VMware, Microsoft, IBM, Huawei, Intel, Amazon, and a bunch of others are all collectively working on pushing Kubernetes further. So many smart people are working on this. What happened with Kubernetes is that we suddenly got a standard API on top of all the clouds. Getting an EC2 instance is a different API call from getting an Azure container instance, and it's definitely different from getting a Google Compute Engine instance. All those are also different from the VMware API in a private data center. With Kubernetes, we all got a standard API across cloud and on-prem. Why should we care about this standard API? Because of software, of course. We had ECS before Kubernetes, so we could run containers before Kubernetes. There were many other offerings, but they had a very small community around them. With Kubernetes bringing a consistent API, a lot of people and companies were motivated to write software on top of Kubernetes. You could now write software for Kubernetes and reach customers across cloud and on-prem. That was a massive, massive, massive deal. So much software was written for Kubernetes, the Kubernetes API and the Kubernetes way of working. Do you want to do machine learning? There are a lot of frameworks that can help. Do you want to do automated deploys and rollouts? There are multiple top-of-the-line bleeding-edge options that can do that for you. There is so much software. That is the big Kubernetes advantage. Remember how VMs compare with containers? If we take away all the fluff, again, it's all processes running on a server. What Kubernetes and the Kubernetes and Cloud Native community did is that they took all of the sysadmin shell scripts and made them stable and reliable. Think all the shell scripts you had to check the health of an application before routing traffic to it. Think all the complex Linux config making sure an app won't take over the server. Think all the restart scripts you have. Think of all the server maintenance scripts you had like rotating logs and expiring logs. Kubernetes basically took all that code, it put an API on it, it moved it from Bash to Golang, a more powerful language, and standardized the APIs for communicating with tools that do all that. The result is awesome pure power. You'll learn more about that from Walid on September 28th, when we will actually be learning how to run applications on Kubernetes. We've covered a lot today. Let's do a quick recap before we get to the Q&A. So, containers are smaller than VM. Containers enable teams to move faster, and containers are compatible with existing applications and existing frameworks. You don't have to rewrite your applications. Containers are highly customizable, and containers have better cost efficiency than VMs, but lower than serverless. But the big deal of containers is software. The lots and lots and lots of software built on top of containers that allows you and your business to focusing on delivering value. How do we run containers? Well, ECS is the AWS built way. It works great if that's all you need, and I highly recommend it. If that's not enough though, if you need more power, if AWS is not enough for you, or if you want to push the services even more, if you want to be on the bleeding edge, Kubernetes comes to the rescue with its amazing power and very vibrant community. That's it. That's the very short and compressed why and how of containers. So what's next in this series? This week we don't actually have a workshop, but next week will be fun. Next week we'll cover the next topic, actually building container images and storing those images. On the 21st of September, we'll do the talk discussing the workflow and how you can actually build containers. On the 22nd of September, we will do a live workshop building containers for different applications. It's going to be awesome, it's going to be interactive, and it's going to be a lovely experience. After that, I will pass it off to Walid, who will teach you how to run containers on Kubernetes. You'll learn how to harness that amazing, amazing, amazing power of Kubernetes. So definitely make sure to tune in on September 28th for an awesome talk and workshop on Kubernetes. Again, was all powered and supported by our awesome sponsor, AMD. Thank you, AMD, for sponsoring this series of talks. That's it. That's all for today, folks. Thank you so much for being here. Let me stop the screen sharing thingy and we'll do the Q&A and have the actual social part of the meetup. Again, we've tried not to absolutely get you confused with a lot of information, so we're going to be discussing all your questions and concerns now. Let's get to it.
Hello.
Could
So
you
there are many
guess-
questions. Yes.
Yes.
I mean, it was quite interactive, which I love it. And I think we don't need to do the raffle. We have already good people asking questions. For example, Sidarat, Amr, and Yalmot. Is this Yalo Thomas? So basically, Yalo Thomas, Sidarat Joshi, and Amr. Please try to contact us in LinkedIn or me or Anas, and we'll give you the AC, sorry, not EC, AWS vouchers.
Thank you.
Now, the first question, Vlad, was about serverless. And the questioner assumes that serverless is more scalable than containers. And you promised him that you will answer this question.
Yes.
So I want to know, is serverless more scalable than containers?
Yes and no, of course. I mean, it would be too easy for us to have a clear answer. Nothing is ever easy.
There is never something clear, yes.
Exactly. So the thing with serverless is, especially with stuff like Fargate, stuff like Lambda containers, stuff like App Runner, is AWS manages capacity for you. So if you need to scale up suddenly, say you are running 10 servers and you have to scale up to 1,000 servers, you have two options. You either create that infrastructure right then, so you create all those, 990 servers right then, but you have to wait and it takes a while, or you have parts of the servers or some servers waiting for traffic. Neither of them is ideal though, because if you're having infrastructure prepared, you're paying a lot of money for it. So you're basically just throwing money away, and I don't like doing that. And if you launch the instances right then, you have to wait for them to come up. You have to wait for them to actually be able to receive work and receive requests. So it takes a while. With serverless, and again, by serverless here, I mean both Lambda and Fargate. With serverless, you're running on AWS capacity. So for AWS scaling 900 instances, that's easy. They have a lot of capacity. They don't have to stress about it. You get to take advantage of the economies of scale that AWS gets. So that's the first reason that serverless is usually faster. Now, of course, it depends on the workloads. Lambda specifically can, one Lambda container can actually only serve one request at a time. A container running on EC2, running on Fargate, be it ECS or EKS, it can serve multiple requests at the same time. Depending on how your requests look, you might be getting faster scaling with one or the other. So you always have to test it. Again, I had the reInvent talk on this that ran in the, reInvent part 2 in January. That's gonna be outdated, but if you were scaling to less than 1,000 containers, Fargate was faster than EC2s. If you were scaling above 1,000-ish containers, EC2s were faster. But again, there's a lot of customization that you have to do there. And an important thing is AWS keeps improving their services. Like, there's not much to improve on launching EC2 instances. That's done. But AWS improving on managing their capacity for Lambda, for Fargate, a lot of improvements happening there. And AWS is actively working against this. So on average, I'd say serverless is faster than containers in scaling. It's also scaling your team much faster because you don't have to worry about as many things. Does that make sense? Anas, Walid, anybody else want to add something to my answer?
It makes perfect sense. I mean, as Vlad said, there are lots of factors and there is the scalability, and I think it always matters your context. Also, how about the cold start? What do you think about cold start and serverless compared to Fargate and stuff? How does it?
I hate that question. Cold
Sorry,
starts haven't. No, it's a very, very good question. But cold starts haven't been an issue for like a couple years. When Lambda was initially launched, yes, cold starts in VPC were in the range of seconds, like 15 to 30 seconds. It was terrible. Right now, it's super, super, super small. So cold starts are not that much of a concern. They are still there for Lambda. Likewise, if you are asking Fargate to give you a node, it takes a tiny while. But those are pretty small things, and unless you're doing super high performance stuff, I would not stress about it. Cold starts are a problem of the past, and the fact that everybody's linking to blog posts from 5 years ago saying how big of a problem cold starts are, we really need to be staying up to date with this.
Okay, and there were some questions regarding Knative versus serverless, and is serverless in AWS was based on Knative?
You cover that. No, it's not. Knative came way after. Lambda is actually running on Firecracker, which was open source by AWS, if you want to look into it.
Yes, Firecracker is a very nice virtualization, let's say. Very minimal virtualization.
Yeah, it's fantastic what's happening with virtualization right now, because
yes,
I had in my talk, like, containers are not VMs, but right now we also have VMs that can behave like containers, and we have micro VMs, so the line is getting quite a bit fuzzy. But I still love that analogy, even though it's technically wrong, like not correct, but I love it because it makes it easy to understand how containers run.
Okay, Sedarat was asking about container runtimes, and he was asking, does AKS allow us to choose or modify container runtime?
You link to a blog post. I know people were trying to do proof of concepts for containerd and benchmarking containerd, but I personally did not change the container runtime, so I couldn't give you a definitive answer.
Yeah, it's a nice question, Sedarat, especially for gvisor. I need to go out and read this blog. I haven't read it before, because you need like a nested virtualization. So you have to really be careful what you're doing there. And there was questions, when should I choose ECS versus EKS? And this is actually an overloaded question.
Well, wanna take the first swing at it, Walid?
Well, first, if you want to use ECS, you have to be like an AWS customer. So if you are in AWS and you have use cases, or you're just adopting containers and you know that you are staying with AWS, ECS is a good way to get started quickly. It's simple. It's you can grasp it very quickly. And it's another orchestration that not many people talk about. I mean, Kubernetes won the game. Kubernetes won the industry. So it is the de facto orchestration. If you need portability, if you don't need the lock-in, and you need to be everywhere, EKS is the way to move your workloads from one cloud to another to on-prem. But however, last Wednesday, AWS released EKS Anywhere, where you can run EKS even in your on-prem, or you can run it in any development environment using something called Docker Provider. So this thing, like Vlad said, things are changing. What is like 4 years ago is not true anymore. And this question, again, I say it depends on your context. What kind of workloads you want to import or run on ECS versus EKS? Or if you want the ecosystem for example, observability tool, monitoring, logging, and things like this. Sometimes I feel it's easier in Kubernetes than it's on ECS or on container orchestration environment because of the ecosystem of Kubernetes. I mean, that's my opinion. What do you think, Vlad?
It's definitely a loaded question, and the answer changes so often. So again, ECS came before Kubernetes, and how should I put this polite? It was terrible. It was absolutely terrible, and very few people were actually using it because it wasn't fully built. It gave you weird errors that you couldn't understand, and there wasn't a community around it, so you couldn't chat with anybody about it. It was not a good experience. And then Kubernetes came in and it had an awesome community. It had very clear errors. It had a way better development experience. So Kubernetes became the de facto orchestrator, as Walid said. It was the best proposition. But in the latest years, AWS really got basically a kick in the butt from Kubernetes to improve ECS. And ECS improved massively, massively in the last years. And I expect a lot of changes are still going to happen. Kubernetes is going to be ahead. ECS is going to be ahead. Kubernetes is going to be ahead. ECS is going to be ahead. AppRunner is going to be a thing. You always have to keep yourself up to date. That said, today, if you're running on AWS already, I'd start with ECS and Fargate to be specific. And whenever that is not enough, I would move to EKS. So do you want to do, like doing GPUs right now, you cannot do GPUs on Fargate. So if you want to do GPUs with ECS, you have to run EC2 nodes. EC2 nodes in ECS are not great. They're slow, they're scaling quite slowly. You have to debug a bunch of things. It's not ideal. And AWS is deprioritizing EC2 nodes with ECS. So AWS is putting priority on ECS and Fargate. So if you can run ECS on Fargate, definitely do that. If not, again, the power of Kubernetes is there for you, and it's something that you can pick up. And you can very easily combine them. One more thing I would add here is ECS anywhere is also a thing. You can now run containers into your own data center managed by ECS. If you can combine that with AWS Outposts, you can have some pretty interesting architectures. I have some clients that are very, very excited about what you can do with that. And it's something that is easy, or allegedly, to do than Kubernetes. Again, it depends on what your requirements are, what your team knows, what your team wants to learn, where your strengths are. It's a loaded question.
There is, again, another question by Muhammad Atiyah regarding Fargate and what's the relation between it and ECS and EKS. You answered it, but maybe you want to give him the...
Sure. Sorry, let me drink some water.
Yes.
My throat is a bit dry. Yeah, so Fargate is not a service by itself. Fargate is a compute option. So think of Fargate as an alternative to EC2. With Fargate, instead of running a full virtual machine with OS and things like that, you're running a container image. That means AWS can do the patching for you. You have to, you don't stress as much about maintenance. There was, when was this? Last year, there were a bunch of terrible vulnerabilities, including in sudo. How many of you patched all your EC2 instances for that absolutely terrible vulnerability? AWS does the patching for you if you're running Fargate. So think of Fargate as easier compute. Fargate is not a service by itself. Again, think of the brain and the workers. That's an awesome image that kind of explains the concept pretty well, I think.
Mohammed also asks when to use Elastic Beanstalk, and I guess he means when to use the Elastic containers in Elastic Beanstalk versus ECS and EKS.
So again, as we've learned when AppRunner was launched, Elastic Beanstalk is now in maintenance mode, so it won't be receiving any major new features. Of course, AWS can change their mind, so I would kind of stay away from Elastic Beanstalk for new applications.
However, AppRunner is not in all regions. Like, for example, in the Emirate In the Bahrain
App-
region, it's not there.
App Runner is just a terrible proposition right now. In my view, you cannot connect to anything in a VPC. That is not an acceptable limitation for me. If you're just running web apps or just doing things like talking only with DynamoDB, which you can access over the internet, it might work. For me, though, it's way too limiting right now. But
Okay.
again, App Runner is the next evolution of fully managed containers from AWS. So I expect it to mature fast. And in, 2023, I expect it to be the way of running containers. Until then, though, depends how many requirements you have.
Yeah, I can make an analogy. I mean, for me, it's like can I say it's like Cloud Foundry, and this S2I in OpenShift is basically where you just point to your source code and the platform takes care of everything.
That's a very good analogy. I love that.
Muhammad also has another follow-up question. Muhammad, come on, how many questions you have? Yeah, there is a limit.
It's very good. We're very much encouraging. Ask all your questions.
Okay, so he
I
says,
waited for this. I waited for this. By the way, you told us that there is a Q&A at the end, so I waited at the end.
don't wait for the end. Yeah, no worries. So
Okay.
his follow-up question is basically, can you give us a use case where we can start with Elastic Beanstalk and then move it to EKS, since all can work as a microservice?
One of your applications. If you have something like a web API, those are usually the best example applications. Or if you just need something super easy to run just to play around with, and you don't have a business case or you don't have a workplace where you can actually test that, there are a lot of Hello World applications that you can run. I personally open sourced a series of distributed Hello World applications. It's basically a Hello World made of 3 services. You can find them on my GitHub if you want to look for them. I'll link to them. And I'm using those applications in workshops, in trainings that I do with my customers to showcase the difference between different orchestrators, the power, how to configure, how to run. So that can be an option, and there are a lot of other Hello World applications. But by far the best way of learning and migrating a workload is taking one of your business applications, one of the application that is actually supporting your business, and playing around with that and seeing what's the best fit for it.
Okay, another question from Muhammad again is basically how to convince customers, cultural question, that are already using Kubernetes on-prem to move to AWS. I can answer this, Muhammad, because I have this use case already, but I cannot actually move to AWS. I have like 4 to 5 OpenShift clusters, but sometimes I'm limited because I am on-prem. I cannot just create another cluster using Terraform, for example, provision similar cluster to test an update or to test an upgrade or to test something. So this is the simplest use case is testing and development. I want to test something quickly and tear it off. I mean, there are lots of use cases. We are on-prem because of data residency and data governance. Vlad, do you want to take a shot at it?
Yeah, there are use cases that are not a fit for the cloud, and that's okay. A lot of people run in data centers, and it's a valid and totally okay proposition for them. If you're doing a lot of networking, AWS billing of network traffic is not very friendly, so you could get absolutely amazing cost savings from running in an on-premise data center. If you're doing something that has very thin margins, it might be a good idea to run in a local data center. The cloud is not always a choice, but yes, the biggest advantage of the cloud is how fast you can move. You don't have to wait, what is it, a couple months for a new rack to come in? Your developers,
Yes.
what if they're waiting, I don't know, if they're testing an application and processing that takes 3 hours? In the cloud, you can just get a bigger instance and do that in 3 minutes. Unblocking your developers to move faster. That's the big proposition of the cloud. So yeah, it depends. If you want to convince a customer, you have to make the business case for it. Why is there a business reason to move to the cloud? And there
Can
might be,
we,
or they might not be a reason.
Sorry to interrupt. I'm very sorry. Can we integrate multiple, multiple platforms if the customer is working with OpenShift and, like the
Yes.
Kubernetes itself? Can we integrate like some sort of replication to be AWS to be in the middle so that it can, connect the company branches all over the world or the company locations?
Yep.
Visibility or multi-cluster? It depends. Is it federation or is it just visibility? With visibility, there was a
Federation.
product. Sorry?
Federation. Control,
Federation.
manage.
So federation, you need a product like Rancher, for example. I don't believe EKS. EKS Anywhere is focusing on infrastructure. It doesn't have the multi-cluster management functionality yet. And you can raise it in GitHub. You can raise it as a feature request. So you need something like Rancher or like the open source project Hive, which basically, there are other projects. I mean, and there are several levels of federation that you can do. So there is the, is it called KubeFed or Fed2? I forgot now what it is called. So federation is not an easy thing. IBM donated to Red Hat the multi-cloud management, MCM, which is, I think it's called Cloudback for multi-cloud management. They donated it. So it's in Red Hat. It's called Red Hat Advanced Cluster Management, which is based on an open source Hive. And you can use that to link between different Kubernetes cluster, regardless of which cloud, regardless of which distribution. Or you can use Rancher. Rancher is a very good product. It's supporting EKS Anywhere. It's an application that runs on top of a Kubernetes cluster, and you manage other Kubernetes clusters. And you can do backup, you can do restore, you can do lots of functions with it. I need to revisit because I believe they just released a new version. Okay.
Thank you so much, Walid. Very awesome session. Thank you so much.
Thank you for your time, and thank you for your questions. Your last question about project Antria. So Antria is a CNI from VMware, and it's supposed to be a very lightweight and very feature-full set CNI. And AWS have, I believe they have a roadmap to support it. They have something called CNI plugins, and Antria is one of them. Calico CNI. Calico is I think is the most popular, but yeah, Antria is part of the ones that is going to be supported. Yalo Thomas, he's not a question. He wants us to do more security. I would love to do that, Yalo. By the way, KubeCon is just around the corner, and there is co-located events, and one of the co-located events is the security day, where it's the capture the flag. And this capture the flag, it will be different than last year's, and you will learn. It's not like a competition. It's more like collaborative teams or collaborative individuals, and you will be given hints, and you'll learn a lot, and you will learn gradually. You'll start with a simple challenge, and then you move to a blue or red team, and you'll get more harder challenges, and you will learn along the way, and there will be streaming and stuff like this.
That sounds awesome. Is that
yes.
just for the in-person KubeCon in LA, or is this available to remote?
This is available to remote. There will be 2 Twitch streams explaining some of the challenges along the way. It's an all-day long capture the flag, and Kasten, the backup company, and I think also Trilio, they do offer free virtual tickets by just joining their mailing list and stuff like this. And you need to pay $20 to join the security day. So yes, we will add security. I love security, so we'll add something security, and we maybe can ask actually. We can do a capture the flag session if there is a popularity.
Thank you, Walid.
Yeah. Anas, what are you asking here? Oh, you're not asking, you're answering. Okay. Oh man, are there any benchmark results available of EKS in comparison to similar GKE EKS? You can do them yourself. Vlad, are there? Yeah, there are actually.
They're way too different though, so I wouldn't necessarily compare them that way. I mean,
Yes, but what
I-
matters to you? I mean, if it's a
Exactly.
company, what does it matter to you? The cost, the security, what does it really matter to you? For
the
example,
integrations, the
yes,
latency. I, for
mainly,
example, really love Kubernetes on DigitalOcean because it's not a major cloud and I can run testing from DigitalOcean to AWS to applications running on AWS. Because let's be real, testing AWS apps from AWS is going to be very flawless. Being able to test that from DigitalOcean or from another provider is a big draw. So it depends on what you want and how they compare.
yes. And Siddharth, there is, I mean, as Vlad said, Kubernetes is not limited to these giants, AWS, Google, and Microsoft, and Oracle. There are like Civo, for example, which is a K3S cloud. There is a Scaleway in France, and they target developers. You will see how easy it is to learn their command line tools from day one, like the first hour, and you will be productive straight away. So the benchmarks, you might need to elaborate on this.
There was another question regarding cost, comparing ECS with EKS. So I also have a section on this in my reInvent talk. You should really watch that because cost is not as easy to estimate as you would think. So first of all, it's infrastructure cost. Like ECS clusters are free, EKS clusters cost $75 a month. Not a big cost, but if you're running, 10,000 clusters, it can add up. But ECS is also a bit easier to manage because it's integrated by AWS. AWS does a lot of management for you. For example, AWS does a lot of management around integration with ALBs and routing traffic. You
That's
don't
the
have
next
to
question.
upgrade awesome. You don't have to actually upgrade the ingress controller and do tweaking around that. AWS does that for you. So if that's enough for you, ECS could be an awesome option. But yeah, it depends. Maintenance is more expensive on Kubernetes than on ECS, but you get more power.
And when it comes to cost, and when it comes to anywhere, and if I take the same example that Vlad took regarding the GPU, so there are benchmarks that says that if you are really using machine learning and you are doing lots of deep learning and you need GPUs, sometimes the cost of running the GPU on-prem is much cheaper than running it on the cloud. So if I take this example and I use ECS anywhere and my workload is running on my site, on my prem, or in a different cloud, depending on the price of the VM and the GPU, and sometimes you will not find GPUs, the cost of ECS anywhere is less than $10 US per node per month. I mean, it depends on your region and other factors, but roughly that's the cost. So it's really, really a good option. So again, it depends on the context and your circumstances. Okay, so there was a question about how to get traffic into ECS and EKS. And what's the difference getting traffic to ECS and EKS in terms of support for ingress controller, private cluster, persistent storage, etc. Persistent storage, Ankit?
ECS and EKS, again, do kind of the same thing. They're both cars. One is, a Mercedes, one is a BMW. One is pizza, the other is a burger. It depends on what you want and what you need. Let's actually take ingress as an example. So if there are two major way of doing ingresses, you offload the ingress to AWS. In ECS, that means using the ALB integration. In EKS, that means using the AWS load balancer controller. That means that traffic is going into the application load balancer and then directly into the pod. That's awesome. You're offloading a lot of effort. Not much difference there. On Kubernetes, though, you can also run other ingress controllers. Stuff like traffic, like Kong, like Nginx ingress, like ingress Nginx, which is different from the previous. You have a lot more options. But those options come with a cost. You're basically now running your own load balancers. You have to maintain your own load balancers. AWS has hundreds and hundreds of engineers working on their load balancers. Can you really manage a load balancer at that level? Is it that much worth it to you? In some cases, yes. Like I love some of the ways that Kong and Traffic can do authorization and routing and things like that. In other cases, it's not really worth it. So yes, ECS and EKS both do the same thing, but they do have different features. In terms of persistent storage, I haven't actually experimented that much with it. Is FSX for Lustre available for ECS? I don't know.
Lustre or EFS, yes, but Lustre, I'm not sure.
Neither am I. It depends. Check your requirements. Again, it depends a lot on what your needs are. But again, EKS is more extendable with added cost of having to maintain and configure and run that.
Yeah. Vedant Bajaj, he is asking, I have a cluster in EKS and AKS, how do I manage the system health? Ankit answered him Rancher. So Rancher is one way, basically, when you are thinking monthly clusters. There are other tools other than Rancher, but Rancher is one way, especially if it supports the major public clouds. And supports...
Sorry
Go
for
ahead.
interrupting. AWS also launched EKS cluster connector in preview when they launched EKS Anywhere. That's not managing clusters, so it's definitely not on the same level with the tools that Walid mentioned. Rancher is by far, but you can now get other clusters into the AWS console, so you at least get visibility into that.
Yes.
It's in preview though.
Yeah. Okay, for a lab test, can I use a Bastion host and SSM to connect to EKS cluster and worker node as private and integrated each other? So I guess he's saying that he wants to manage the worker nodes using SSM.
Yes, you can definitely do that. SSM is well supported on EKS. I also would urge you to look at Bottle Rocket. So what AWS did is they launched an operating system that is specifically tuned for containers, and they have some very, very interesting security features around connecting to nodes and managing the nodes, including audit and things like that. But yes, you can definitely do that. Again, EKS nodes, EKS EC2 nodes are just EC2 nodes. Whatever you can do on normal EC2 nodes, you can do on EKS nodes.
Okay, there was a direct message. Somebody is asking me which companies are providing KubeCon tickets. So almost all of the sponsors, they are doing it in their mailing lists. So Red Hat is doing it for students, and also CNCF is doing it for students. You have to follow OpenShift TV, or you have to ask some of your local CNCF ambassadors. They have access to free tickets. But I know for sure Kasten is doing it every year. Okay, for the second year, because this is our second virtual year. And Trilio, I believe, and I can find out if you direct message me in Twitter or LinkedIn, I can send you the link, or I can actually post it. With a huge focus on sustainability these days, which container service, in your opinion, is the most green in terms of energy efficiency?
I love that question. And it really, really annoys me that AWS doesn't publish some more data on sustainability and trying to push the focus on how to run efficient cloud services. On the other hand, cloud is by definition more efficient than data center. I don't know, to be honest with you. AWS is not publishing any data on this, so we don't know. Anything we would be saying here would be speculation. Based on that, I'd say that maybe ECS is a tiny bit more green, because ECS is using more services on demand, it's better tightly integrated. Maybe. Again, I don't know. I'd love to get a blog post from AWS on this or some more visibility into that.
I don't know also, but I know for sure, and don't ask me how, that most cloud providers, when they enter a new territory, they are focusing on green. So they start asking for alternative energy. This is their first questions before they start building a new data center and stuff like this. All of them, especially AWS, and you can see this in the keynotes from 2000, starting from 2017 or something like this, that they have a target to achieve in terms of green energy and stuff like that. But yes,
they build their own concrete for their data centers to be greener. Also, there's a list of what is it? Of data center of regions that are running on 100% renewable energy on the AWS website. There are a couple of regions that are fully renewable or running on fully renewable electricity or something like that. Might be worth looking into.
There is an IBM engineer, Honey, I forget her name. In her name, there is the word Honey. She gave a keynote on KubeCon about this issue, about basically how data centers are the ones that actually could cause more damage to the, what you call it, the zone, the
planet, yeah.
Yes. So basically damage to the atmosphere and stuff like this. And she highlighted what we can do to prevent that. So, I mean, responsible companies are aware of this. And this is actually our last question. And somebody was going to ask questions.
Walid, this is Ankit. Hi, Vlad.
Hi,
Walid.
Ankit. Thank you for answering the Rasher question.
Yeah. So I wanted to touch base upon, a question basically, which was specific to persistent storage, so I just wanted to understand if ECS or AKS does really have any sort of support on persistent storage. So I'll give you a scenario basically. Okay. So for example, if I want to run a stateful application in terms of for example, MongoDB. So though there are third-party solutions, I'm not really sure, or I'm keen to understand whether if there is any possibility or chance of having support for persistent storage in terms of disk or something like that. Maybe for active applications or scenario.
So, I mean, when you say companies, like you mean like Portworx, Storage OS, and things like that?
Yeah, that's probably the third party, and the license cost for the same is of course incredible. So I was just trying to see whether if there is a workaround in AWS itself, which could help us to save the cost at that side.
So what is wrong with EBS? Persistent volumes, what's the issue that you have with persistent? You need something like that, like what Portworx give you, like more abstractions, like rate level, like software rate levels and stuff like this. What's your constraint? What's your pain area?
Okay, so basically when I say, specific scenario to database, there is obviously an option. I mean, there is obviously the best practice is to basically attach a disk, for example, with the container, right?
Okay.
Like for persistent storage. So is there a possibility of basically having RAGRS kind of option in specifically in Bahrain region for the data disk or, managed disk?
RGRS?
Okay. Like GRS kind of, or like replication option available for a disk specifically, but that will be also specific to read only will be in the secondary region, right? Because we can't have it like active in both the regions for high availability for persistent.
Yeah, you need backend replication. You need the replication that is out of the box, that you are not managing it. You need it to be managed by the storage provider, like in Portworx.
Okay, so that is the only option, right? Like third-party solution.
I really don't know how to answer this question. I mean, even my familiarity with Portworx is as a user. Yeah, and I love it. I mean, I love StoreOS, I love Portworx, I love these solutions because they give you several abstractions. They give you different, for example, with Kubernetes, they give you storage classes and they are fine-tuned for your specific workload. So you can say MongoDB, you can say Postgres, you can say MySQL, and you can have 3 different storage classes that they have tuned specifically for this specific workload, or you can have other workloads. And you can tune it also. You can actually customize it. You can create your own storage class based on this and stuff like this. And you can control how many replicas, you can control the availability, the performance. There's so many things that you can tune, but it comes tuned out of the box. And they have many use cases that you don't need to worry about. And they have the snapshot and the restore and the backup and the application mobility. I mean, we spoke about Kasten giving away tickets to KubeCon. I like Kasten as application mobility. Like if your application is, you want to do this replication, you can do it with Kasten, by the way. So you can still, Kasten can do like, what they call it, a streaming backup. So while you are actually running, you can have another backup copy from the application level, not from the storage level, that is moved to another cluster. Okay, actually it's a cluster. So maybe this answers the multi-cluster things at the storage level. So maybe we can address this question again in another meeting, but it's a good question. And I don't know how to answer it really. We can ask and find out. Vlad, do you have any, especially in ECS, I really don't know what the answer is, but in EKS, definitely these companies, StoreOS, Portworx,
So,
and actually it's not called Portworx anymore. It's called
storage.
Pure Storage or something like this. Yeah.
I am not that familiar with such intense options of persistent storage. I would urge you, though, to be very careful of running databases in containers. You can't do it. I'm not saying you can't, but it's an added risk. Also, you mentioned wanting to be
Pure storage. It's known as pure storage. Sorry.
Okay.
So
you also mentioned wanting to be multi-region, which is a super intense thing to do. Keep in mind that one region in AWS is built out of multiple availability zones, which are made out of fully separate data centers, fully redundant buildings that are separate and miles apart. So that may be something you would be looking into. But yeah, I'm not that familiar with such intense persistent storage requirements, so I cannot tell you.
Yeah, I'll tell you. Actually, this question is coming from, my recent experience that I've had with Azure specifically. So in UAE North and UAE Central, there are 2 data centers, right? And there is a latency of around 4 milliseconds between each data center. Now, this is what I'm talking about the region level, not even at the zone level, because zone is not supported at all, in the UAE region for Azure, Microsoft data center. So, I mean, that is, of course, case-to-case scenario. I will not really want to compare it at every single level. But yeah, there was a requirement of, having a Redis cache, high availability across the region for, one of the banking customer. So that is where I was trying to basically come across different options which were there. So pure storage was one of the options where, we can do that. But again, then that basically works in an like active passive scenario. It is not like active scenario. However, Redis has its own option of having the Redis cluster itself, but it again needs an enterprise license for the Redis. So altogether, it kind of makes a big huge investment for the services. So I'm trying to basically understand what is the best possible option, or what is the workaround when we keep it purely native to cloud itself. So yeah, that is where I was trying to, because now I will also have to do this in AWS in the Bahrain region. So trying to map the possibilities of what can I really consider as a prerequisite.
What is Vlad? Did he disappear? You kicked off Vlad, Ankit, man. What did you do?
I'm so sorry. I'm so sorry.
Oh, he's here, but you have sound or not? Okay.
What's happening?
The screen changed. So somebody left, and I think the screen pattern changed. I don't know, Ankit. I think you are the best one among us 3, probably, or amongst all of us that can answer this question, because apparently you have done your research.
No, I'm sorry. I'm just trying to share my experience and, trying to see what can we basically come across from our experience to actually add on to what we can do next. So yeah, that's what.
You say 4 milliseconds. So I think you are still within the threshold range for most of the replication solutions. Usually it's 10 millisecond, correct?
So sorry, you are talking about specific to what exactly?
Between the two Azure regions in Emirates,
Yeah,
you said
4 milliseconds. So between the UAE North and UAE Central, which is, I suppose, in Dubai and Abu Dhabi, it's the latency is around 4 milliseconds.
Yeah, so this is a good latency, isn't it? I mean, it's less than 10 milliseconds. I need to check this, but usually most of the replication solutions, this is the first requirement they ask, that the latency should be less than 10 milliseconds.
Exactly.
Apart
For
from the RDO and
database,
RBO, and yes,
correct.
but you're asking active, so you have to be reasonable even also.
True.
When it says active. I mean, you can be active, and then your RDO would not be. And this is for Redis, you said?
Yeah, the scenario was Redis, but earlier I came across this MongoDB situation also. So I was trying to see, because there was one open source solution that I used at that time, but it didn't work. It was very old. I mean, like 3 to 4 years back, but I don't remember the name, to be honest. But anyways, yeah.
There is Linode or not Linode.
Something ending with .io as the open source.
Everything is .io.
Yeah, true. But